Good morning all. Today in this tutorial lecture I am going to discuss about how we can able to convert SOP form into the POS form. Let us start discussion with the basics of what you mean by the SOP and what you mean by the POS term. As you can able to see, this is nothing but a product term A dot B. This is another product term A bar dot B, and this is third product term A bar dot B bar dot C. Now if I take summation of this all the product term, it's called SOP form. So let me clear what we can. So this is the first, second and third. They are nothing but are in the summation. That's why this is called, we call as a SOP. Now what about the POS form? If you look at over here, this is the first summation A plus B. Here the A bar plus B and A plus B plus C. If I take the product of all these three summation terms, that's why we call as a POS term. So this is the next. Now, what are the procedures to convert one form to another form? Let's suppose if I want to convert the SOP form to the POS and the vice versa, there are the two basic rules we have. First, you need to take a double bar of the function. Okay, what are the function is given, you just to take the double bar of that function, and second step you need to apply a De Morgan's law to break the bar and change the sign. Okay, let us take one example to clarify it more. Let y equal to AB plus BC plus CA. I have one Boolean equation. What is this first step I told you? Take the double bar of the function. So y double bar is nothing but a AB plus BC plus CA double bar. Okay. Now if I'll break the bar like A dot B bar, B dot C bar, C dot A bar, and the whole bar. Now apply the De Morgan's law here. So what it can be? It can be able to A bar plus B bar. Here it will break the bar, change the sign, so B bar plus C. Now you can able to see this is nothing but a SOP form. I had converted into the POS form. This is the one way to convert the SOP form into the POS form. Now next thing, why we are converting this SOP and POS form? Because let's suppose if I have any Boolean expression and if I need to convert that Boolean expression into the using the NAND gate, what I need to do? First, let's suppose I have this function. I know that I can able to implement this function either using 2 input AND gate and 2 input OR gate. But same Boolean expression, if I want to implement using the NAND gate, what I need to do? You follow the same procedure what I told you. That's 2 steps. So first steps, let's try convert this into the SOP form first. Okay, then take the double bar of the function. So it's nothing but AB plus AC plus BC plus ABC double bar. Now I apply the De Morgan's law. What I have A dot B whole bar, B dot C whole bar, C dot B. Now don't again break this bar, the A bar plus B, because we need to implement this Boolean equation using NAND gate. So I must require A dot B whole bar. Okay, so if I try to implement, I required 1, 2, 3, 4 and 5 NAND gates I require. Let's suppose 1, 2, 3, 4 and at last I require 1 NAND gate. Now let's suppose if I want to realize the same Boolean expression and I need to implement using NOR gate. What I will do? Again, don't like here, remember if you want to realize the expression using NOR, then Boolean equation must be in the POS form. Now if you are going for the NAND gate, the Boolean equation must be in the SOP form, but here using the NOR we must have to convert into the, if it is in the SOP then convert into the POS form. Okay, so it's nothing but a you know about the rule A plus BC, that is nothing but a one rule that I can able to split into A plus B and A plus C. Same B plus C, I can able to split B plus C and B plus A according to the rules or the theorem what we had seen in the previous tutorial lectures. So again, first step 1, take double bar of the function, apply the De Morgan's law, that is A plus B whole bar, A plus B whole bar, B plus C whole bar, and all are in the summation. So this is nothing but a POS and this is nothing but a SOP form. Now try to implement. How many NOR gates I required? I have 1, 2, 3. Now don't break this bar and again change the sign. Okay? Otherwise, you need to improve using the NAND gate. So better to have a same expression A plus B whole bar. So I can implement 1 plus 2 plus 3 and then all the other information that NOR gate. Okay. Now let us try to implement. There is another also way to implement using like suppose you know about the standard SOP form and the canonical SOP form. First let us discuss about what you mean by the standard SOP form. So I have one given function f equal to a bar c plus b bar c plus abc plus a b bar. Let us try to implement first in the KML. So if I know this a bar c is a bar and C is common in this and this, so both are 1 1. So try to implement and you put it the 1 for the SOP form. Now remaining are nothing but a 0. Now what is the equation for this 0? I suppose if I'll take a group of this 2, so it's nothing but a now it's nothing but a, for the POS it's nothing but a, here it's nothing but a B plus C, here is here is a BC, B, C bar, B bar, C bar, B bar and C. So it's nothing but A plus what is the common in this? C. So it's A plus C. Here if you will take for this 2, it's nothing but a B bar plus C. So this is nothing but a POS form. Okay. Now let us try to convert canonical SOP into the canonical POS form using the KML. So this is a function I have. Again, it's nothing. So for the canonical, you must have to convert first this term into the canonical SOP form. So for the canonical SOP form, which term is remaining over here? There in this term, B. So I can write A bar C B plus B bar. For this term, which term is remaining? A is remaining over here. So for this, I can write A plus A bar, that is a 1 into B bar dot C. So again B bar dot C into 1, that is always be equal to B bar dot C. So I will include the term which is not there in the what you call Boolean expression. Again here all the 3 terms are there, here C is not there, so I can write here A B bar C plus C bar. Okay, so now try to, after doing this, just multiply all the terms and try to implement where the terms are A bar plus. So it's nothing but A bar C, B plus B bar, A plus A bar, B C. That are all the things I just need to add the term. Now multiply each A bar C with B and B bar, so you will get this term. Now these are nothing but in the canonical SOP form. Now try to implement using the KML method. So these are nothing but the terms what we have, and finally we'll get 1. Now for the canonical POS, you need to take individual term of the POS, like individual zeros you need to take. For the zeros, I can write A bar A plus B plus C. Now for this, it's A plus B bar plus C bar. Again for this 0 is nothing but A bar plus B bar plus C. Okay, now add this all in the POS form. Okay, so like function is equal to A plus B plus C and A plus B bar plus C, A bar plus B bar plus C. So this is nothing but a canonical POS form. This is how. Let's suppose now if you want to implement this term using the NAND or NOR, take the double bar and take the apply the De Morgan's law. You can able to implement using the NAND or NOR logic. So this is what how you can able to convert and what are the difference method using the standard and the canonical. So thank you for watching. So if you have any questions, you can mail me on my mail ID, theshreyas.charula@marwadieducation.edu.in. Thank you. Have a nice day.